This time we'll be looking at how we can calculate half-life periods of a radioactive substance. And half-life period is a time in which half of the radioactive substance is disintegrated. Remember, in our previous class we established that N is equal to N naught E minus lambda T. Very important. And in trying to establish half-life periods, we're going to base on this formula. So if N naught is the number of radioactive substance present at T equal to 0, then the half-life period becomes N naught all over 2. And in this case, we know that T now becomes T half, which is the half-life period. So if this we established in our previous class as equation 3, if this equation 4 and this equation 5. So if you now substitute equations 4 and 5 into equation 3, where we see N is N naught over 2, and where we see T is capital T subscript half. So this becomes N naught all over 2 equal to N naught E minus lambda T, where we have T now become capital T subscript half. So our interest here is this, which is the half-life. So how do we navigate from here to make T subscript half the subject? Remember, this is the left-hand side and this is the right-hand side. So whatever we do to the left-hand side, we must also do to the right-hand side. So we have N naught. We have N naught. So this, okay, let's not cancel at this moment. We can write this expression as half N naught equal to N naught E minus lambda this. So by the time you multiply this, you still have back this. So we have not done anything strange to this equation. It's still the same. So we can now cancel this. So we are left with half on the left hand side and E minus lambda T this. One will be wondering, how can you make T subscript half the subject? It is simple. We can also do this. We can write this as half equal to 1 all over E lambda T half. We can also do this because we know from indices, if I have something like A raised to power minus 1, I can write it as 1 all over E. So here, when I have something like E raised to power minus lambda this, I'm free to write as 1 all over E lambda this. So this is what happens here. So at this point, we can cross multiply and say that 2 this by this equal to E lambda T half. So we want to make, this is exponent. The only way we can do this is to take the natural log on both sides. And by the time you do that, have ln 2 equal to lambda t half. You have succeeded in eliminating the exponents, and you have this. So t half is equal to ln 2 all over lambda. So from your calculator, the value of this becomes 0.693, 0.693 all over lambda. And this is a decay constant. So the implication here is that if you know the decay constant, you can calculate the half-time. And if you know the half-life period, you can as well calculate the decay constant. And this becomes equation 6. Thank you.